Abba Father, we thank you for the gift of our life. We thank you that you've enabled us to attend this lesson. Though some people are still there, oh Lord Father, and they would like to attend this lesson, oh Lord Father, enable them to attend it, oh Lord Father. Guide us. Let us be able to understand today's chemistry, oh Lord Father. I've put this lesson into your hands. Amen.
Amen. Thank you very much for that wonderful prayer. And today I want us to maximize our minutes that we have. We are beginning at 2 and we shall be ending at 4. So that 2 hours we have, we shall be able to utilize them very well. Last week, on Monday, we looked at industrial processes. And in that lesson, we were able to look at part 1, where we looked at a number of things. I would like us to have only one person to remind us what we covered in the previous session. And as that person prepares, I need to let you know that in this session, we shall be looking at our last part. That is industrial processes, part 2. And this is our last part. We believe by end of this session, we should be done with each and every industrial process that we are supposed to cover in this topic of Senior 4. So it's teacher Isaac Nyimbibi who will be leading us in today's session. Let me have one person to remind us, what did we cover in the previous session? By show of hands. Let's try to be a little bit faster. We can also utilize the chat by listing for us what we covered in the previous session, or you can raise up your hand so that we can be able to move on faster. Fahima, are you still there?
Yes, teacher.
Were you there in the previous session
No,
on Monday?
no, this is my first time.
Okay, your first time.
Yes.
Okay. Okay, someone is saying in the chat that we looked at metal extraction. Yes, so last time we were introduced to industrial processes and we are able to look at a number of extractions, and we looked at only metal extraction, where we're able to cover how iron is extracted from its ores, aluminium, and then we're able to see how copper is also extracted. And then someone is saying, and sir, and me, it's my first time. It's okay. Those who are attending for the first time, don't worry. The first session will be shared with you in the group, but this session also will be shared so that you can be able to follow, and then we make sure that we maximize each and everything is as regard to industrial processes. Okay, now, when last time we were able to see the element of construct where industrial processes are extracted from, and we say that this is element of construct number 1. This is just a recap so that we get to know where we are for those people who are joining us for the first time. And we say that this is an element of construct where we expect a learner to appreciate. We expect a learner to appreciate contribution of chemistry to our economy. And then we say that the accessible areas, these accessible areas include manufacture of oxygen and nitrogen gas. So in this session, in the previous session, someone was asking, how can oxygen be manufactured? How can nitrogen be manufactured? And today's session, we shall also look at manufacture of nitrogen and oxygen gas. So that is number 1. Another item, it can be about chlorine gas. This is one of the items that came in the year 2025. Last year, we had extraction or manufacture of chlorine gas. Then we also have extraction of metals, which we covered. This was covered in the previous session. We have manufacture of biogas, which is covered in Senior 3. Detergents also in Senior 3. And I believe for these notes, you have them. But this is a reminder that when you're looking at industrial processes, when you come to Senior 4, that is the climax of industrial processes. And we expect by the time we reach in Senior 4, these other processes, you already have them on your fingertips. In the previous session, we had a number of learners asking, how can I master all these industrial processes? You can master them by practicing, because these are not very many. What you need to do is to practice, and you make sure that at least each and every week you have practiced maybe like 4 industrial processes, and remind yourself you practice. The more you practice, the more you become perfect. So that is detergents. We have manufacture of sodium chloride, which we are going to cover in today's session. We have manufacture of sulfuric acid, which you covered in senior 3. Manufacture of cement and lime. We said cement and lime, we shall cover them in today's session. Then we have manufacture of ethanol. This was covered in senior 3. And then fertilizers. Fertilizers, this is something that we're going to cover in today's session. So today's session, we shall be looking at fertilizers. That is number 1. We'll look at cement and lime. That will be number 2. And then we shall look at sodium hydroxide. That will be our number 3. And finally, we shall look at chlorine gas. Now, for other things, I believe you already covered them. One thing which is missing out here is maybe industrial process for manufacture of charcoal, which I believe... Charcoal. You covered this in carbon in environment, where you're looking at manufacture of charcoal from wood and manufacture of charcoal from the waste organic matter, where you looked at briquettes and different styles of briquettes. Yeah? Fahima, are you there?
Yes, teacher.
Yeah, so I believe when you look at all these accessible areas, we know very well that these ones come in section B. Item what? Which item? Item 3 and item 4. That is section B part 1. So section B part 1 is about industrial processes, and it is a must. It has to be there. Industrial processes must be there in the standard paper. And where are the questions coming from? The items are coming from this area that we are seeing on our screen. So we always have 2 items, all of them coming from any of these, and you are supposed to select only 1 item. So surely we expect at least a learner to maximize this area. That's why we said let's begin on this part, because it is an important part, very crucial. In the next week, we shall be looking at another part for section B, that is natural resources. We see how do we approach natural resources, which items can come up from natural resources, and we look at all those. As that, if it is section B, we say that we are now done with section B. The next time we can be able to look at section A, item 1 and item 2. But I know you're somewhere already. Okay. If you have any question, you can still ask, but I would like us to move on. Just that this column, the last column here, processes involved. These ones are things that we expect a learner to include when you are looking at the process of production. We expect in the process of production, a learner to include a vessel. A vessel, these are the materials that the apparatus that you're using. So expect in your procedures to mention maybe this was put in a reactor vessel. So we expect those in the, maybe when I talk about extraction of iron, we need to see the blast furnace somewhere. So we need to see all those vessels in those procedures or those processes as you list them down. Then a chemical process, we expect to see at least a chemical process when you're carrying out any experiment. So there's that score for a chemical process identified. Then there's one thing that we missed out here, which is PP, the physical process. I believe we shall be able to identify a number of these as we move on. Then we have CD, which is the conversion to the desired product. We expect in your procedures, at one point, we expect to see a learner mentioning how the product is coming from a raw material into the desired product. Then we say that coherence, this score you get it when your work is organized in a logical flow, logical manner, from step 1 to step 2 to step 3 in that order. So you have to make sure that as we are looking at your procedures, as you're looking at the process of production, your procedures are very well organized and arranged. Then finally, another score comes in when we put this part. This is always among the last parts. We're looking at the purification process. So expect any substance that you manufacture, we expect you to do some purification. And we now have different ways of purifying different substances. Some substances undergo fractional distillation for purification, like ethanol. Then there are those ones which you need to just dry, others you need to wash so that they become pure. So different purification processes can be important as we're looking at industrial processes. Unless someone has a question, I would like us to move on to our first part. Let me look at the chat. Teacher, please try to be loud. Fahima, is it true that you're not getting me clearly?
No, it's not me, teacher. I'm hearing you clearly.
Then Abigail Bakayo, you need to check. Maybe Abigail's phone is the one which is having the volume down. So you can work on that. What of us who are not in the group, sir? Like I said, in the chat, I've already put for you the link. Let's click on that link. If you're not seeing that link, I can still drop it there. Check on that link. It will be able to direct you to the group. Okay, now let's move on. Just one person who is raising up the hand, and then you can move on. Philippa. Yes, Philippa. Philippa?
Excuse me, teacher.
Yes, please.
When we were studying industrial processes, our teacher told us that it's okay to use like chemical formulas and like we don't write anything. So will we still get the marks for the processes involved, like the vessel and like all that? Like we'll get the marks because when we're using the formulas, there is no way we are going to indicate the vessel. So could you please explain?
Now, did they tell you that when you use only formulas, you get all marks? That's what they said? Hey, you have gone. Maybe to just elaborate for even other learners, when you're looking at industrial processes, you're looking at the manufacture of oxygen, manufacture of chlorine, then you use only formulas, meaning that some scores you're going to miss out. Now, your equations and the formulas you're using may be coherent. Maybe you get that. But in your process, in your equations, if you don't include the part for purification, then you get it. No, you'll miss out. The score for vessel, you will miss it out. But these other ones, you may get them. Now, the teacher told you that if all things have failed and you have those equations in your mind, then you can try to put that. But that is when you have failed to recall the process. But if you know the process, then why do we need to put only the chemical formulas? And the good thing, these chemical processes are not hard for us. So let's try to put the chemical formulas alongside the process of production. The ones, let's put all the vessels, we include all those so that we don't miss out any score. Yeah, those who are raising up the hand, I know I'm coming to you, but let's also use the chat. Now, like I said, in this session, we shall be looking at fertilizers, and some of the fertilizers, we have the ammonium nitrate, we have ammonium sulfate, we have the urea. And you recall when you're looking at these fertilizers, the first thing we look at is nitrogen. Most of them are coming from ammonia, isn't it? They're coming from what? Ammonia. But you recall the raw material for ammonia is nitrogen and hydrogen. Nitrogen and hydrogen. So that's why I said, let's also look at nitrogen today before we look at these fertilizers, the ammonium nitrate, the ammonium sulfate, the urea. Then after looking at those, we shall also look at the alkalis and the chlorine manufacture of alkalis, which is the sodium hydroxide, and then the manufacture of chlorine gas. Then we shall also look at the manufacture of cement and manufacture of lime. When we are done with that, we shall call it a lesson and we stop there. So those are the things that you're going to be looking at. And to start with, we shall be looking at how nitrogen is manufactured. How nitrogen is manufactured. Those who are putting up the hand, let me hope that you have the response for nitrogen, manufacture of nitrogen. Let me ask someone here. Tiala? Yes, Tiala. Okay, Tiala is not speaking. When you put up the hand, always check and see whether I've allowed you to unmute. Then we can move on. So Tiala, you're not unmuting. ITL S6, yes.
Chama, I think nitrogen is made the same way oxygen is, just that they are collected at different boiling and melting points.
So are you telling us that we use which method to manufacture nitrogen?
Separation of air.
Yeah, so we are going to look at separation of air, and we separate air by what?
Through fractional distillation.
Through fractional distillation. Can you take us through very fast how fractional distillation occurs, and we make sure that we maximize our scores? Make sure you identify the vessels, you identify the physical processes taking place, the chemical processes taking place, the raw materials, you identify the conversion to the desired product. We also talk about the purification, and then your work should be coherent. These are things that I would like us to look at. And a good thing, I've already put for us the picture. Are you able to see the picture here?
Yes.
Yeah, I don't know whether we can analyze and you take us through as we look at this picture, what is happening, and just a simple brief, take us through briefly there.
Okay, so the raw materials involved are air, silica gel, and concentrated sodium hydroxide solution.
So
The
yes.
production air, silica gel, and then concentrated sodium hydroxide solution.
Good. Let's move on.
So the production process involves filtering of air to remove dust particles. Then after, the air is passed through a container containing concentrated sodium hydroxide to remove carbon dioxide in a formula of carbon dioxide plus concentrated sodium hydroxide solution gives you sodium carbonate and water vapor.
Okay.
Then after that, the air is passed through silica gel to remove water vapor. the reason why carbon dioxide and water vapor are removed is because when they're exposed to low temperatures, they can easily freeze. So the dried air is passed through an expansion chamber. And it is allowed to expand and also pass through water-cooled coils.
Okay.
So as to cool the air. So after that, the process is repeated until the air liquefies. Then it is compressed, and after being compressed, it is transferred to the fractionating column, and hydrogen is the first to be removed with its boiling and melting point of negative 186 degrees.
That is what?
Its boiling point.
Boiling point of what?
Of nitrogen, it's negative 196 degrees. Yes. Then it is collected and stored then after it is collected and stored in a gas cylinder.
Okay, thank you. Can we clap hands for her? Let me see. That was Aitel. Your name is?
Martha.
Martha. Thank you very much, Martha, for taking us through. Yes, I can see people are clapping hands. Good. Thank you very much for leading us in the manufacture of nitrogen gas. And like she told us, if you know how to manufacture nitrogen gas, then even oxygen becomes very easy. The difference is the boiling points, that nitrogen has its own boiling point and oxygen also has its own boiling point. But nitrogen having a lower boiling point, it comes out fast. And then followed by the oxygen, which is having now, you can see, negative 183 degrees Celsius. Before I display my results here or my work, let me hear from Tiala and then we can move on. Tiala and the Guy Lusu. Anyone who unmutes faster, you'll be the first one to speak. Guy Lucy or Tiala, unmute.
Hello, teacher. When you're doing the industrial processes, are there any information that we need to include apart from the vessel, the chemical process, then like the
and
purification?
when you talk about look at this, when you look at the chemical process, that's where you also include like equations, and these equations can either be in word form or they can be in symbolic form. But all other things, you'll find out that we're including them here. Maybe I'm going to display my work and then we score it. Maybe can I display it and you read for us step by step?
Yes, teacher.
Okay. Here it is. You can take us through. It is there. Let's move on. There. Are you able to see that?
Yes, teacher.
So maybe you're going to take us through the process of production. Let me first take us through the raw materials. So on the raw materials, we're saying that we have atmospheric air, or someone can just say air. These ones, you don't need to put them also. For me, I'm putting it here like this because just this is our discussion. But for you, when you're responding to your item, if you're using air, use air. If you're using liquid air, use liquid air. If you're using atmospheric air, use atmospheric air. So don't put atmospheric air or air like the way I have done here. This is for our revision. Then we have silica gel or silicon dioxide, and then we have concentrated sodium hydroxide. So you have this, you're able to get all your two scores. So on the raw materials, you get all your two scores. But if you don't first list your raw materials first, you can include them in your process of production and you still get your scores. So if you include them in your process of production, we give you all the 6 scores at once. But if you have already if you have already listed your raw materials, meaning your raw materials will give you 2 scores, and then the process of production will give you 4 scores, giving us the 6 scores. I believe that one becomes very clear. So the process of production, let's look at this. So you have air is passed through air filters. These are things I want us to always take note of. Air filters. This is a vessel. And why are you passing it through air filters? To remove dust and smoke particles. Now, when you're removing dust and smoke particles, this is a physical what? Process which has been identified. We are removing. There is no new substance which is being formed. Here, it is just a physical process. Removal of dust particles, removal of smoke particles. Then after that, you're saying that air is then passed through concentrated sodium hydroxide solution to remove carbon dioxide. Now, when we do this, you call, someone was telling us, when you get air, pass it through concentrated sodium hydroxide solution, we are removing the carbon dioxide. And when we're removing this carbon dioxide, this is a chemical what? Process. A new substance is going to be formed because it will be sodium hydroxide. And then in our final product, you'll find out that we have this sodium hydroxide is going to absorb the what? The carbon dioxide from the air. So we shall form another new substance there. And then we have air is passed through. Now here, we have not included the word equation, but we say, as we said, we have to include the word equation. Because of the space, I didn't include some of those word equations or the symbolic equations. But I know, we know very well that. Then we said air is then passed through silica gel or silicon dioxide to absorb water vapor. So this is another chemical process. Then carbon dioxide and water vapor are removed from air before it is liquefied because they solidify and block the pipes of the apparatus. So here we are looking at why we are removing the carbon dioxide and water vapor initially before we move on. We will first remove the two. And why are we removing them? Because they can easily solidify and thus blocking the pipes. Then the remaining components of air are repeatedly, there is LY here, are repeatedly compressed at 200 atmospheres and allowed to cool at about negative 200 degrees Celsius to obtain liquid air. Then the liquid air is fractionally distilled using fractionating column. Now, fractionating column is another point for the vessel. Nitrogen boils off fast because it has a low boiling point of negative 190. Now, this is nitrogen boiling out fast. This is conversion to the desired what? Product. We're getting our desired product, which is nitrogen. But like I said, because these procedures can work for both oxygen and nitrogen, you see, I said leaving behind oxygen with a higher boiling point of negative. Now, this one we may not include, but I have put it here for us to know that actually, if they have asked you to manufacture oxygen, separate oxygen, the procedures will remain the same. Where the difference is on the last point. here we collect our oxygen at negative 183. While for this case, since we are on nitrogen, we are collecting it at negative 196 degrees Celsius. So the boiling points are the ones which differ. Then we didn't end there. We're saying that the nitrogen is then stored under pressure in the steel cylinders. So we have, at this point, we come to the end, and we can see that our work is organized in the following steps, from step 1 to step 2, moving on. So which means we also have our score for coherence. Our score for coherence is already there. Why? Because our work is already organized in a chronological manner. Unless someone has a question, we can still move on. In this case, we have covered two things. Nitrogen, we have covered nitrogen. We have also covered for oxygen. Just to Gordon. Yes, Gordon.
Yes, Master.
Yes, please.
Good afternoon, sir.
Good afternoon. How are you?
Fine, sir.
Mm,
I'm asking that
mm.
why some teachers when we form such what preparation when we try to the procedure without the equations
Hey, that one I
they
talked
say
about it. I talked about it. I said that at this point we put the equation, and you say that equation can be in word or symbolic equation. Use the one you know very well. But I said
eh,
because of space, that's why you see these brackets. I said here you can put the equation for reaction with
it's,
sodium hydroxide, reaction
eh,
for silica gel. So we need to include those ones. I believe those are major
so
equations we have here.
master
Yes.
if I use the word equation it's okay.
Very much okay. It is also equation. You can use word equation or you can use the symbolic equation.
Thank you, master.
Okay, welcome. Another one is Fahima. Your hand is up.
Yes, teacher, I have a question.
Mm,
Teacher, when attempting such a question of industrial process,
mm.
is it a must for you to put the side effects and what mitigations when they have not requested them in the question?
Very much. Now, when you're looking at industrial process, actually that's where we're going. If you look at our next slide, we can't end there without looking at the side effects of the production process and the social benefits of the production process. That's where we're going on our next slide. So you have to
So,
put them there, whether they have asked it to you or not. That is section B, part 1. Section B, part 1, we have to make sure we look at production process, we look at the side effects of the production process and the social benefits.
okay, thank you, teacher.
Okay, welcome. Joanna? Joanna?
My question is like,
Mm,
when I'm answering that question, it is a must for me to put that diagram in my process.
no. The diagram was helping us during our discussion here.
In
Just
what
the diagram, diagram is helping us to visualize that we start with atmospheric air, yeah, entering and then removing carbon dioxide, removing the water vapor. It goes through the compressors just for our revision here, or in
we
your
don't
research in your notebook, you get. But when you're answering, we don't expect a learner to first draw the diagram because
okay,
whatever we need is already in the process here. Yeah.
that was my question.
Okay. Thank you, Joanna. Gift. Let gift be the last one, and then we can. I know we can use the chat. Gift. Gift. Or Zainab.
Master,
Okay. Yes, please.
master, the
Yes.
question that it's
Mm,
like when I'm getting this question,
mm,
they say right a note about those people that they have ignorance on making such, like on manufacturing oxygen.
Yes.
Do you start by the saying manufacture of oxygen, or there is a sentence that you first write?
Oh, and most of the time you'll find that in the task they're asking you to the task they say as a chemistry student make a write up. Yeah.
Mm.
Now, when you're making a write up, it's good for you to put a subheading and you say manufacture of oxygen. Are you seeing that? Then you put
Yes.
material, process of production. Then you put it down very well. After that, you put another subheading. During the production process, there are some side effects that occur. These include, you put the side effects, which are very well explained. Are you seeing that?
Yes, teacher.
Yeah, so it is a write-up.
Can
In chemistry, we don't expect you to start by saying, now I'm Tiala, I'm doing this, I'm coming from this. So we don't need those explanations. We are not in English. But what you need is a write-up with those subheadings. You tell us you're looking at the manufacture of oxygen.
Teacher, another question is,
Mm,
like I joined when you're saying
yes.
that when we are manufacturing oxygen,
Mm.
like we manufacture two at a go, that it's oxygen and nitrogen. Then I didn't understood that.
Okay. Okay. So, gift. What I was meaning there is that this process here, it can work for the two processes, for nitrogen and oxygen. Yeah. Like for now, we have been looking at nitrogen. Are we together?
Yes.
But even when they ask you to manufacture oxygen, the process will remain almost the same. The difference will be on the final part. Here we are collecting nitrogen, which is being stored, but when it is oxygen, we shall be collecting oxygen at negative 183 degrees Celsius. So the difference is here at the collection points. Here we are collecting nitrogen at negative 196, while oxygen is being collected at negative 183. Are you seeing where the difference is? But these other things remain the same.
Thank you, sir.
Welcome. Now, gift, look at this. Read for us. Read that. Gift, are you seeing on the screen? So on the screen, we see that we have side effects of the production process. Uh, Maybe let me have someone we move together. Zainab. Zainab?
Thank you, teacher.
Mm.
Teacher,
So,
I wanted to ask whether it's a must to put the equations.
yes, I said that equations, we put them there, but we are free to use the ones we know. Whether you know the word equation
Mm,
or the symbolic word equation. Any of the two will work. If you know the word equation, use the word equation. If you know symbolic equation, use symbolic equation and you balance it.
okay. Okay, thank you, teacher.
Welcome. Now, what are some of the side effects of the production process of oxygen or the production process of nitrogen gas? Anyone who can give us one pregnant point, a very good point, which can give you the 6 scores. Someone in the chat was asking how many scores does it take? So there are 60 scores. And this time around, I'm encouraging learners to always put at least, you put at least 2 points, which are very well explained. Who is ready? Catherine, unmute. Namusoko, Catherine. Yes, Catherine.
Thank you so much, sir.
Mm.
When you look at the production process, we are having The one where we have to the purification. I will use this one of purification, where we are storing our nitrogen in under pressure in steel cylinders. So I would say that in case these cylinders burst, they can result into death of people because the gas is being stored under pressure.
Okay, due to high pressure.
They can burst and result into death of people.
Resulting into death of people. Okay, continue. Please, other people can be putting in the chat your points, which are very well explained.
Can I now give the mitigation?
Yeah, when you're giving points here, you have to make sure you give the danger of the danger, also the danger of that, the danger. You explain the danger and then you mitigate it. That's when you get all your marks.
So, sir, I'm not sure about this one, the mitigation, but they can make sure that the cylinders are always valid, like they are really compatible for the use.
You mean when they burst, it means that they are not compatible.
No, in case maybe they have been used for so long.
Okay. Okay, thank you. I know there's someone here who can add on your point. You're called Catherine, yeah? Okay, Catherine has given us the point, but now the mitigation. Can I have host Dave, hostman? Hostman, can you give us the mitigation? Or Galaxy A2? Galaxy A2. Okay, Alvin. Nora. Let's unmute. Let's unmute. Yes, Alvin. Okay, Alvin is not very clear. Because of time, let's use the chat. Because of time, let's use the chat so that we can be able to move on. But when you look at this point, for explosion or bursting of the cylinders, we can just use the mitigation. How can they mitigate this? How do you ensure that these cylinders are in right condition? Meaning we can, by encouraging them to do regular inspections of the cylinders. So meaning they need to keep on checking on these cylinders whether they are in the correct order or whether they are functioning very well to avoid such explosions or the bursting of the cylinders. Yeah. So I want us to move on. Let me just remove this, and then I request one person to read for us what I'm going to display on the screen, such that we can move on. You know, we have a number of things we're going to look at today. That's why I would encourage us to utilize the chat, and also we utilize, if you utilize the chat very well, we can be able to take very little time. Okay, let me have one person to just read for us. Someone who has Jackie. Yes, Jackie? Jackie, unmute. Jackie? Okay, I'll read for you since they're not doing that very fast. Okay, so we are saying that explosion of nitrogen cylinders, that is the point Catherine gave us, or bursting of nitrogen cylinders due to high pressure. Now, there you get your score. When you give such, you get your score. That is a danger which has been identified. Then the liquid nitrogen can cause burns and permanent eye damage, causing injury and hence death. Because when it bursts, which means this liquid nitrogen inside the cylinders is going to spread to maybe people who are nearby, and we're saying that this one can lead to death. So that is the danger that has been explained. Then this can be mitigated by regular maintenance and monitoring. Catherine, let me hope you have seen this. Regular maintenance and monitoring. So this is a danger that has been mitigated. So this point can give you all the 6 scores. But I encourage us this time round to always put at least 2. Put 2 points which are very well explained. Look at my second point. Poisonous fumes by waste gases. Here, this is the danger identified. E.g. exposure to nitrogen in the atmosphere can produce pollutants such as ammonia, which when inhaled can cause respiratory disorders to humans. That is a danger that has been explained. This can be mitigated by fitting catalytic converters in exhaust pipes of the machine. But we should always add to convert the harmful gases into harmless. That's when I give you your score for the dangers mitigation. So here I've given you 2 points, but like I said, I encourage us to always put like 2 points and you explain them very well. Unless someone has, let me check. Please, teacher, help me with some side effects and benefits except job, employment, market. Okay. What is the difference between the process of conversion to desired product and purification? I believe there's a difference. When you talk about conversion to the desired product and purification, you already have your product, but you want it in its pure state. Like when you're looking at ethanol, you already have ethanol, yeah? But this ethanol needs to be pure by removing that excess water, and we carry out distillation to separate water from ethanol. So there are 2 different things, which I believe we can look at that. Then separate from the points using full stop. What is he saying? I think inhaling of the gas by workers and residents in the community causing respiratory diseases, hence death. This can be mitigated by use of proper personal protective gears like nose mask to prevent inhaling the gas. Very good. Rita has given us that nice point, which is very well mitigated. Teacher, can mitigation, okay, let me look at this. Let me look at this point. Okay, I'm not seeing this point very well. Teacher, can the mitigation causing wounds to the worker? This can be mitigated by wearing protective gears. Master, check mine. What is yours? Studies, check mine. Nina, can my mitigation be putting safety hazards for workers on the point of explosion of gas cylinder? Putting safety hazards. What are safety hazards for workers? Nina, you need to explain more to us that point. Then, keeping cylinder in a cool area or avoid exposure to heat. Teacher, what if you first write the side effects, then after you write the mitigation? Veronica, this is a good question, and I would like to first respond to Veronica. What if you first write side effects and then after you mitigate? No. One thing I want to encourage us is to make sure that if you're writing, you write the danger, like the way we have done. Put the danger, explain the danger. After explaining the danger, mitigate in one point. Don't first write the danger and then after you come and mitigate them. No. It's better do this, write the danger, explain it, and then mitigate. Now, let's look at these social benefits of the production process. Someone was saying the social benefits of the production process the social benefits of the production process, we don't talk about the one for government revenue. We don't talk about the employment opportunities. So meaning that we already have these points. Can I have a number of people put in the chat? What are some of the social benefits? And don't forget, if you're looking at the social benefits, your 1 point must have the following. It must be having the benefit identified, the benefit explained, and then you give us the impact of the benefit, so that you get all the 6 scores. So the social benefits gives us 6 scores, and even the side effects gives us the 6 scores. But you can get these 6 scores if you have given a point which is very well explained, and it is having these 3 marking points. These 3 marking points. So can I check in the chat? Let's type the very first, the answers. Let's put the answers there. Employment opportunity, therefore giving improved income, that's better standards. Now this one, Samax Sepalas has saying, during the manufacturing of nitrogen, noise is produced which damages the eardrum, leading to permanent or partial deafness. It can be mitigated by putting, very nice. This is a very good side effect. Please keep it up by putting on those good points. Those good points are very nice, very well explained. Then someone is saying they help in developing infrastructures, source of government revenue. Let me first read for Hostman is saying nitrogen is used in preserving. Now, Hostman was not looking at social benefit of nitrogen. We are looking at the social benefit of the production process. So that point of yours, we won't mark it. When you say nitrogen is used, here you're giving importance of nitrogen, not social benefit of the production process. Someone saying that a source of employment to people since they can work as supervisors, drivers, that is a good point. Someone is saying, is it a must to use a table when you're answering? Please, no. It's not a must to use a table when you're answering. If you're answering, you can do like the way we have done. Put small subheadings and you put your responses. Those tables were used when they are giving you some notes. But now when you're answering, it's not a must to follow the what? The table. Now, teacher, what? Someone, can we apply 2 mitigations on 1 point? Can you apply 2 mitigations on 1 point? Yes, you can apply them. But why? If you have given a danger, you have explained it, give 1 mitigation and you go away. Go and do other things on other items. No need of putting very many mitigations, yet you already have other questions to deal with. Let me hope that one is very clear. Teacher, your voice is too low. I can't hear well. Akankwaza Fidelis, please check your phone. It's possible that Jeremiah, you repost your point. I didn't see your point, Jeremiah. But these people are saying it is source of employment, hence leading to a better. Those points, we don't want them. Tell us, during the production process, there are employment opportunities for maybe the skilled and unskilled, hence which helps them to attain the income, improving on their standards of living. Those are points, pregnant points. I want points which are very well explained. Yeah. Then, good afternoon, sir. What is the mitigation of the noise produced by industrial process? They have already given us the answer. When the noise is produced and the answer is maybe encouraging these people to put on the earpads. We have earpads. Those are the safety gears, yeah? Putting on the earpads can help in preventing the noise pollution, which can affect our eardrum. I believe your responses are very nice. What I can tell you is to make sure that you continue to do what you're supposed to do by explaining your points very well. I want to receive only 2 people with questions, and then you can look at fertilizers. Fertilizers are going to go through them a little bit faster. It is already 3, which means we have only 1 hour remaining, and I want us to use this 1 hour very well. Since we have already talked about side effects and social benefits, when we go to fertilizers, we may not go back into side effects and social benefits. Can I allow only 2 people? Only 2 people to ask questions. Question and answer, just questions. Shiba.
Excuse me,
Yes,
sir.
Shiba. Yes, please.
I thought
Mm,
the side effects are supposed to be to the environment, not to the person. Now, why do you have to say? Why do you have to say that if injuries, they cause injuries, yet it's supposed to be to the environment?
okay. So Shiba is asking, she thought that side effects, we're looking at side effects to the environment. And now, Shiba, are you still there? Shiba?
Yes,
So
I'm
you're
there.
saying that when we say that maybe injuries,
Yes.
which point was that? You
They
pardon
have
that point? Pardon
probably
the
this
point.
one that causes burns. That one that they can cause burns to the person. So I thought these
Oh,
industrial
anyway,
processes are supposed
there
to
is
be
this one.
environmental impact, not
Look at
personal
this.
impact.
Oh, look at this point. You are saying that during the production process, there could be explosion. Are we there? Of nitrogen
Yes.
cylinders due to high pressure. Yeah. Now, when the explosion of nitrogen cylinders happens, you recall inside the cylinders there is nitrogen. Now we are continuing to explain and say that the liquid nitrogen which is inside the cylinders causes burns and permanent eye damage, which are causing injury, hence death to people. These people are also within the what? The environment. Because when these gas cylinders explode, people who are within the industry are going to be affected. That's why we're saying that how do we mitigate this? We need to have the regular maintenance and monitoring of these cylinders to make sure they are in right order. So it is to the environment, but environment, what is environment? Shiba, could you define for us what environment is?
Yes.
What is environment?
The study of man and his surroundings.
Man and his surrounding. Is man part of environment?
Yes.
Very good. So I
Um,
think that that point
now,
remains very
um,
correct. The problem is when you talk about,
yes.
you start by telling us that nitrogen can lead to this. There you're talking about the effects of nitrogen instead of talking about the effects of
Mhm.
the production of nitrogen.
Okay. Then
Yes.
after, can you have 2 points, 2 different points, 2 side effects, but with the same mitigation?
2 side effects with the same mitigation. What
Yes.
I would encourage is when you look at two problems, I believe you can always find another mitigation. Yeah. Don't like
Yes.
decide that we have, because I know you may have points which can be mitigated by two problems, but mitigated by the same thing. But if it is possible, use 2 different mitigations since you have 2 different what points. That could be the best advice to do that. But don't go beyond 2 points. You don't have enough time. Use only 2 points, explain
Okay.
them very well, and you move on. Yes, Peter? Peter, Peter. Yes, Peter. Peter, you're not clear.
I would like to know
Yes. The what?
chemical processes and the
You'd
physical
like to know the
processes
difference between the physical process and the physical processes and chemical processes.
involved in the production process.
Oh, okay. If you look at this, maybe just taking you back a little bit here. When you look at this, we say that removal of dust and smoke particles from air, those are physical, that is a physical process. But when we pass air on the sodium hydroxide, we are going to form sodium carbonate, which is a new product. So that is a chemical what? Process. Are we there? Are we there?
Yeah.
Yeah. So the physical processes, there's no new substance, like there is no change in the composition. When you remove dust, you're just removing physical means. But when you add sodium hydroxide, it is going to react with carbon dioxide to form another substance. So that is a chemical process. Okay. Allow me to move on to fertilizers. Allow me to move on to fertilizers, and then we see how these fertilizers can be manufactured. Okay, just a minute, then I can be able to display what I want us to look at here. I want us to look at this, which is about the fertilizers. And we say that since these are nitrogen-based fertilizers, they are all coming, most of them are coming from the ammonia. They are coming from the ammonia. But ammonia was covered already in senior 3. We already looked at manufacture of ammonia. But you don't need to worry about how ammonia is manufactured, because every time you look at how ammonium nitrate is manufactured, how potassium nitrate is manufactured, ammonium sulfate or urea, we shall still look at manufacture of ammonia. So in one way or the other, we shall look at it. So when we look at the screen here, we're saying that most of ammonia used today is manufactured by reacting nitrogen. This is something we already know, and hydrogen at temperatures of 400 degrees Celsius to 500 degrees Celsius and pressure of 200 atmospheres. Then finally divided iron is used as a catalyst in the industrial manufacture of ammonia. And this process is known as the Haber process. I believe this one, you already know it very well. I'm not saying that this is how ammonia is manufactured, but I'm just bringing to our attention what we looked at. When you're looking at manufacture of ammonia, we looked at reacting nitrogen and hydrogen at these temperatures and this pressure in presence of finely divided iron catalyst to form ammonia. I believe that one is very clear to us. Now we are continuing to say that ammonia is converted into a variety of fertilizers such as potassium nitrate, ammonium nitrate, ammonium sulfate, diammonium phosphate, DAP. I believe most of you know DAP. Those who plant coffee, these are things that you have been using, the DAP, a diammonium phosphate, that is DAP. And we're saying that these fertilizers are known as inorganic. They are known as inorganic. We have those ones which are organic, which are coming from organic wastes. Those ones are organic fertilizer, but most of these we are looking at today are inorganic fertilizers. Now, there are various fertilizers we use. However, some are better than others depending on their nitrogen composition. I believe you know very well that not every fertilizer has the same composition of nitrogen like each and every, like any other. There are those which have a high percentage of nitrogen than others. So here there is a small assignment I want each and everyone to participate in. Please look at it very well, take a screenshot and practice there on in your notebook, and you put your responses in the chat. Each and every one is going to participate here. Fataki Abdul, please, I want the answers for part A. I want answers for part B, answers for part C. Let's try it very fast. What are they saying? Consider the fertilizers given in the following table. Rihanna is requesting to record. Please, this recording will be shared. Don't worry about the recording. So they're saying that consider fertilizers given in the following table. We have ammonium nitrate, potassium nitrate, urea, and their chemical formulas are just here. Now, calculate the molar mass of each compound in the table. Molar mass of each compound. So I need to know what's the molar mass of ammonium nitrate. Put it in the chart. What's the molar mass of potassium nitrate? Put it in the chart. Urea. So I want to see those answers. Then I want to see the percentage composition of nitrogen in each. I want to see those ones. And finally, part C, you tell us the best fertilizer out of the three. 5 minutes should be enough to have completed that. Melvin, can I hear from you as we are doing that number? Let me hear from Melvin. Melvin?
Good afternoon, sir.
Good afternoon.
Sir, for me, my question was about the side effects. Because at school, when we were studying about industrial processes, our teacher was like, the side effects must affect the person who is carrying out the experiment.
No, we
But
say
now
that side
again,
effects. We say that side effects. They are side effects of the production process. And since it is the production process and this process is being carried out within the environment, these side effects are going to affect the environment. And within the environment, we have the human being, but also other things which are surrounding man. Yeah. So when you're looking at the side effects, look at the side effect of the production process, but it is affecting the environment where even man is part of the environment. So I don't know where you had a very big issue, but the point which won't be marked is when you start giving us the side effects, like for that production process of nitrogen, and then you tell us nitrogen causes this. Now they will be giving us the side effects of nitrogen, not the production process of nitrogen. Yes.
Okay, thank you, sir.
You're welcome. Jethro. Jethro? Jethro?
Yes, Chair.
Yes.
Yes. I wanted to inquire whether it's right to leave out the equations when giving the production process.
It's not right, but I said you can use word equation or symbolic equation. Any of the two would work.
Because I was told that you could write the production process without the equation. It would still be marked in a.
No, why do you look for? I know how students have
Like
been
in case of mastering the equation.
Yeah, like I
Like
said, if master of the equation, like mastering the symbolic equation is hard, it's better you use the word what? Equation, the word equation. You will still be marked. But don't leave out because there are those points when it is vivid that here we need to have an equation. don't leave it out. If you see the symbolic is hard, then employ the word equation.
Correct.
Because whether word equation or symbolic, it will still be marked. But
Okay,
Jethro,
thank
have
you.
you finished part A, part B, and part C?
No, I'm doing it right now.
Okay, let's try it faster.
All right.
Okay. AP Noela, AP Apostle, or okay.
Okay, teacher, good afternoon.
Good afternoon.
Oh, teacher, I'm just inquiring. Actually, it's
Mm,
clarification about
yes.
the risks and mitigation.
Risks, no, we don't have risks and mitigation. We have side
Okay, like
effects.
the side effects, teacher.
Mm,
Okay, teacher, like according to what I've been hearing you saying,
mm,
is that we're supposed to like it's supposed to be inclusive in the environment. It doesn't only affect the atmosphere, the trees, and like maybe the animals, but also man himself.
but also what?
Like also man. So like our side effects are supposed to be inclusive, like everything.
Yes, but you may not have a point which is cutting across. It is affecting man, affecting trees, affecting what? Like the one we gave at first, it was explosion of the nitrogen cylinders. And we say that this liquid nitrogen inside, when exposed to human beings, it can cause burns and thus leading to death of the people within the industry. How can we mitigate? We said by regular uh, checks and the monitoring of these cylinders. So here we see. Now, your second point, you can now talk about the next point that when it is exposed to air, the nitrogen can react during the product. The excess nitrogen which is escaping can react with maybe hydrogen present in air, forming ammonia, which can bring up, talk about how ammonia can affect the products which are coming up, waste gases, how they are affecting the environment. And there we said, how can we mitigate? By installing the catalytic converter, which are going to help to convert these poisonous into harmless. Or you can say by treating the waste gases before they are released. So you have 2 points. One is affecting man, and another one is affecting the environment. But still, all these two, it is environment, because even man is within the what? Environment. But we can't have one point affecting man, affecting trees, affecting what? No. But we want to see a
So we
point
have to
which is very
specify.
well, the one which is very well explained. Yes, let us know whom is it affecting and
So you
how.
specify the side effects.
Yes, you can give us maybe a point and we get to know whether it is correct or not.
Okay, like the explosion of the gas cylinders.
Mm.
Like okay, like of nitrogen, like it can cause like respiratory disorders or diseases leading to death.
Now, when you talk about respiratory diseases, now these respiratory diseases, are they going to affect the people who are inside there?
It will.
Yes. So meaning, but when they affect in that way, it can even lead up to what? The death of these people. So you see that point becomes a good point, and then you go ahead and mitigate it.
The mitigation is by wearing gas masks.
By encouraging the workers to put on the safety gears like face
Gas
masks.
mask.
Are you seeing that?
Okay.
Yeah, so I want us to phrase our points very well so that whoever is scoring your paper, like in the upcoming mocks, doesn't have any excuse of denying you your mark.
Okay, teacher, thank you.
You're welcome. Anthony, Okay, Lucy is the final person. Please, I expect us to have finished these items, A, B, and C. And then we move a little bit faster. All fertilizers are going to be done in only 10 minutes because they are very simple. And I know we can do it very fast. Yes, Lucy?
It's okay. Good afternoon, sir.
Good afternoon.
My question was like, what about the other side? I mean, like this one they say, like destruction of the environment, like for instance, trees. How can you mitigate it?
First phrase your point, like on that industrial process for nitrogen.
Yeah, like
Mm-hmm.
destruction of the environment, eh?
How?
Okay, the thing is, why they say like the
Mm,
side effects, like how we let me say the side effects of that thing of the industrial process, right?
mm.
Then there is this point they always tell us from school that the destruction of the environment. So I don't know how can it affect the industrial processes.
Oh, now, when you look at maybe, okay, trees, how can trees be affected right here?
Yeah, that's what I wanted to know.
Yeah, so one thing I wanted to tell us is that not every danger works on every industrial process. Yeah.
Yes.
So it depends on what is being released, what is being manufactured. Now, for example, if you're looking at nitrogen, we see during the process of this nitrogen, we are using the machine. And you saw there's a point where we are looking at compressors, where we are converting from gas into liquid air. Now, these compressors are going to produce much sound. And when they produce much sound, that is noise pollution. And do you know that these sounds, they can affect our ears? They can affect the
Yes.
hearing of our process of hearing. Now, that is a danger. Now, how can we mitigate that danger? So you put how you can mitigate the danger, maybe by putting on the ear pads. That can help to minimize the sound. So ear pads, that can be the mitigation. Then another point we looked at here in nitrogen is explosion of the gas cylinders. So meaning that depending on the question, depending on what you're manufacturing, that's when we can look at those other side effects. Now, let's talk about like the process of manufacturing like detergents. If you're manufacturing detergents, which means that the leakage of some of the products or the things that the raw materials you're using into the soil can affect the soil. So that is pollution of the soil due to the what? The leakage of the raw materials during the manufacture of detergents. Are you seeing that? Which can affect the fertility of the soil, that's leading to poor or to low crop yields. Lucky, are we there? Okay. So what am I saying? Depending on the industrial process, that's when we get to know which side effect. Let's not cram the side effects, but understand what is involved, what is being produced, and there you can be in position to respond. Techno, I want the answer for part A, part B, and part C. Techno. Yes, Techno. Techno BG. Please, right now I want answers. Let me check in the chat whether we have the answers already. Okay. Potassium nitrate is 138.2 grams. Okay. And you have a paper there. Okay. So someone is saying that ammonium nitrate, oh, that is good. People have already calculated the percentages. And someone is saying that ammonium nitrate is the best because it has the most nitrogen. Oh, very good. Potassium nitrate, people are saying, someone is saying, Eileen is saying, for potassium nitrate, it has 138.2 grams. That is Eileen. Okay. Let me check another person. Then another person, Akankwasa Fidris, is saying that potassium nitrate is 101. Now, those are different answers, meaning there is a problem. Rita is also saying 101. Ammonium nitrate, someone is forever young, is saying it is 80 grams. Okay. Then someone is saying urea is the best fertilizer because it has the highest percentage of nitrogen. I see that we are having different answers. That is Paloma. Then Jeremiah, Derek is saying that no, it's urea. Then Jeremiah is saying that I think urea because it contains the highest. How do we find percentage? Zainab is asking. Okay. Ammonium nitrate 80 grams. Urea, sir. Hanifa is saying urea. Good. Now we can prove our answers whether they are correct. Let's look at this. Now, when you're looking at the molar mass, let's try it out together very fast. And I want to be seeing, can I move with someone who has already calculated by show of hands? Tiala, unmute, Tiala. Unmute, Tiala. Are you there?
Yes, teacher.
I want us to move a little bit faster. If you're talking about, let's start with ammonium nitrate, yeah?
Okay.
What do we do? Calculating its mass, molar mass. Nitrogen, we have two of them, isn't it?
Yes.
Meaning to be 2 times what? Be faster.
2 times 14.
Good. Plus hydrogen, how many are they?
There are 4 atoms and each carries 1. So 4
Good.
times 1.
We are remaining with the
Oxygen. 16
Yeah.
times 3.
Let's do faster. 2 times 14, mathematics.
28.
4 times 1.
4.
And 3 times 16.
48.
When you sum up this, what do you get?
80.
80 grams. So those who got 80 grams, clap. Let's mark ourselves. Those who got 80 grams for ammonium nitrate, you're very right. Okay, let's run very fast. Potassium nitrate. Can you move faster? That would be 1 times what? 39.1, isn't it?
Yes.
Nitrogen, we have 1 times Z.
1 times 16. 14 plus 16 times 4.
3 times Z, 16. So this becomes 39.1 plus 14 plus 40. What is the answer?
105.1.
What?
105.1.
105.1 grams. Is it true? Have you used your calculator very well? Can I have another person? We move together when we are two. I want 2 people now. Anthony Cole. Let's move together that with 2 people.
It's 91.
It is?
91 confirmed.
Okay. 91. Let me also call. But this boy is not open. Unmuting. I tell S6. They're going to move together. 3 people. That way. I tell S6.
Yes.
For you, what do you get?
I have 101.1.
Tara now. So what is the answer?
101.1.
Okay. That is the correct one. Tala, what are you saying now there? Yeah, even me, I'm getting 101.1 grams. Yeah, that is the correct one.
That's
That is
the
the
one.
correct one. Okay. Finally, urea. Urea. Nitrogen, how many are they?
2.
So 2
There are
times
2.
14. So let's move together now. Hydrogen, there are how many? So it is 4 times
There
1.
are 4.
Carbon.
Carbon 1.
So 1 times
Then
12,
oxygen 1.
oxygen 1. Are they done?
Yes.
Okay, 2 times 14,
28.
4 times 1.
24.
Here it is, 12
12.
plus 16. What is the answer?
60.
Is it true?
Oh,
58.
20, 30, 40. What is the answer? You see,
60.
yeah, at 60 can be right.
60
Just mental
grams.
work. 28 plus 4, 32. Plus 12,
60.
44. So that is 60. So please, those people who have different answers, check yourselves whether you're getting it right. Oh, and by the way, this is practice of more concept. So in industrial process, you see that we are practicing even more what? Concept. Now, I want us to do the percentages. The percentages. Here we have for ammonium nitrate. Ammonium nitrate. Here I have urea. Here we have potassium nitrate. Someone was asking, how do we get a percentage? Can you tell us?
I think it will be nitrogen, the mass of nitrogen
What's the
over
mass
the
of?
total. Here it's
Very good.
28.
So let me use red so that you can see very well. So here there are two nitrogens, which means it is 14 times 2, which is 28 over. The total was what for ammonium nitrate?
80.
80. Then we multiply by 100. What
100.
is the answer?
35.
35%.
30?
5%.
Like that?
Yes.
Yes.
Urea. Urea is here. How many nitrogens do we have in urea?
1. So that's 14 grams.
Nedda, check. Urea.
There
There
are
are
two
two.
atoms.
So meaning it becomes 28 over
28 over 60.
60 times 100%. So the answer becomes,
46.7.
yes,
46.7%.
it is
46.
46.7%.
0.7%. Let's go to potassium nitrate. For it has only one, meaning it will be
Yes.
14 over 101.1 times 100. What is the answer?
13.8%.
13.8%. Are you seeing that you have already finished part B? Now, part C. Identify the best fertilizer out of the three and give the reason. So from here, which one
Urea.
becomes the best fertilizer?
Urea.
So those who had urea, you're very correct. Why are you choosing urea?
Because it has the highest percentage of nitrogen,
The
which means
highest percentage
that
of
of
nitrogen.
nitrogen, meaning that a small portion of urea can be used to to be applied in a large portion of land.
Yeah, very good. So you see, which means if you use potassium nitrate, you need a kilogram to do a small thing where for urea you could have used a very small what portion. So meaning the one which is having a highest percentage of nitrogen, it becomes the best fertilizer, and in this case we say urea is our best fertilizer. Let's now wind up with fertilizers, and the first one we're talking about is ammonium nitrate. Now I know you have already done this and you have different ways you have approached them. But for me today, I'll be taking us through to see what are the questions, what are the things that you have encountered in this line that are still challenging you, and also encouraging you to continue reading every day to make sure that you have an industrial process you have practiced so that you don't forget them. So when you look at ammonium nitrate, if you recall, these fertilizers, by the way, they are all like salts. They are salts. We have ammonium nitrate is coming from ammonia. It is ammonia and an acid. Which acid is that? Ammonium nitrate. Nitrates come from which acid? It is nitric what? Nitric acid. So even when we're looking at manufacture of fertilizers, we are still using our knowledge that we have already discussed in the beginning. We make sure that we look at the process of production, side effects of the production process, and then the social benefits. Maybe I just have one person to take us through if anyone has a question. Now, before someone takes us through, we have a few minutes and I want us to use them very well. If you look at ammonium nitrate, I have done it using two methods. Here I've listed the raw materials where we have the nitrogen gas, hydrogen gas, finely divided iron catalyst, and platinum rhodium catalyst. And then the production process just there, from here to here, and you get all your four scores. Look at this. The first stage, those ones I told that you don't need to worry about ammonia. Ammonia is already covered here. Look at this from here. This is manufacture of ammonia. So did we need to first take you through ammonia? Because we're going to look at it here. Look at this. During Haber process, nitrogen obtained from air reacts with hydrogen from natural gas in a sealed container. This is our vessel. And when nitrogen reacts with hydrogen gas, that is a chemical process. In the chemical process, in a sealed container at 450 degrees Celsius and 200 atmospheres in a ratio of 1:3 respectively, in the presence of finely divided iron catalyst to form. This is a conversion to one of the desired products. But of course, this is not our desired product, but it is formation of part of the products we are looking for. But finally, our final product is ammonium what? Nitrate. So the gas is then purified, liquefied, and refrigerated. And here is our equation. So in this case, we have already looked at ammonia. After getting ammonia, see, during catalytic oxidation of ammonia, what happens? Ammonia gas is oxidized to nitric oxide gas in sealed container. This is still the vessel. Oxidized, that is the chemical process. In a sealed container in presence of platinum rhodium catalyst, and then the nitric oxide gas. There's an equation which I missed out here. The one which is where we're having ammonia being oxidized to form nitrogen oxide dioxide gas. This one is the one I missed out. And of course, but the good thing we have this. So I'm saying that the one which is produced nitrogen dioxide gas then reacts with water to form nitric acid. And here is our equation. You see, finally, both nitric acid and ammonia gas are heated in a neutralizer reactor tank to form ammonium nitrate fertilizer, which is then purified, concentrated, and packed. And here we have our equation. We get all our four scores here, and then our two scores, we got them at that point. I think I'll get all the 6 scores very, very fast. But before we ask some questions, I also said we can use another way. Instead of using catalytic oxidation of ammonia, I believe some of you have used this method. Look at this. I want to display the whole of it just there, and you're done. That's why I said last year, by the way, in 2025, one question was about a nitrogen-based fertilizer, meaning the one who used this got the answer right and got all the scores. And the other question was about chlorine, which we are also going to look at in this session. So please, that's why I say there's no reason why you should get a B. Let's look at A's. Look at this raw material. Nitrogen gas, hydrogen gas, finely divided catalyst, and concentrated nitric acid. Here you get all your 2 scores. These are the raw materials. Raw materials. This is raw material. This is the raw material. Now, when you come on the production process, still we start with the Haber process, manufacture of ammonia. So I'm saying that nitrogen is obtained from air. Nitrogen, but obtained from air, reacts with, this is a chemical process, reacts with hydrogen from natural gas in a sealed container. This is our vessel at 450 degrees Celsius and 200 atmospheres in that ratio, in presence of finely divided iron catalyst to form one of the desired products. And then the gas is then purified, liquefied, and refrigerated. Our equation is there. Then after that, look at this. Concentrated nitric acid is reacted with, you recall concentrated nitric acid. This time down, we have it as our raw material there. So it is concentrated nitric acid is reacted with ammonia in the reactor, forming ammonium nitrate solution, conversion to the desired product. So that both the nitric acid and ammonia are heated in the neutralizer tank. Hey, this is not it. So I say that both nitric acid and ammonia gas are heated in the neutralizer tank to form ammonium nitrate fertilizer, purified and concentrated, and then packed. You also get your 4 scores. Total scores here, there are 6. But of course, we don't end there. We go ahead and look at the side what? Effects and the mitigation. We also look at the social benefits. Unless someone has a question, but if you don't have, we can move on. Tiara, any question or we just move on?
So we can move. I'm okay.
Okay. Anyone with a question, put in the chat. I see very fast before I move on. Which coil is this, guys? I'm new. Now, excuse me, sir. I'm kind of requesting you to add me in WhatsApp group. Okay. My number is this. One of the members here will be able to do that. Will be able to do that. I'm just giving you the link, which you can just follow. Those who are asking, which process is better, teacher? Someone is asking now, which process is better? They are all better. Now it depends on you, which one you have liked or which one you have. Teacher, please help me identify the vessels in the materials we have listed. Okay. I thought I've mentioned the vessels. You see here, neutralizer reactor is a vessel. That's why I'm putting V1. And you'll call it, when you say purify, this is the purification. Yeah. So you look at other vessels here. Another vessel is here. Sealed container is a what? A vessel. I believe I have answered that very well. Okay, so which tips can do to get the industrial processes easy? Like I said, practice makes perfect. When you practice, you'll get them very well. Master, last time I tried the group, it was full, so I couldn't join it. Oh, please, like I said, use that link I've put in the whatever. Then I'll be able to see whether we can get for you the group which is not yet full, and then you can be able to join the group. Yeah, the link is there. You can also subscribe there so that you can be able to continue. Please, I can hear you. Good. Very nice. So we are done with that. For side effects, these ones we talked about them, but I'm just going to repeat for the last time since I've put more points here. Someone was saying that, so this one, we already looked at it. Explosion of ammonia gas cylinder. Ammonia gas cylinder, this is a danger due to high pressure They're saying ammonia has irritating smell and causes permanent eye damage, causing injury, hence death to people. This one is the danger which has been explained. This can be mitigated by carrying out regular maintenance, almost similar to the one we looked at, but this is a different product. Now look at another one. Air pollution from nitric oxide gas, particulate matter, and ammonia gas. This lowers air quality in the area. So these are two. This is a danger. This has been explained. Can be mitigated by use of electrostatic precipitators and ammonia absorption system. This is the mitigation. Here I'm giving you a number of points, but like I said, you can always use like 2 points, and then the examiner will score 1 and you get all your 6 scores. But for our revision, let me give you more. Look at this. Noise pollution from compressors that may cause discomfort and hearing problems to the residents. Are you seeing that? This can be mitigated by use of soundproof in production rooms. Or if not soundproofs, we can also use the protective gears like ear pads. Those ones can work also. Then prolonged exposure to ammonia gas cause a potential risk. Prolonged exposure. This point, let's eliminate it. Why? It is talking about exposure to ammonia. Maybe if we had said that during production process, the waste gases like what? Ammonia. Not directly. We will say that during production process, there are some waste gases which may escape, like what? Ammonia gas, which can cause potential risk to the respiratory disorders and the eye irritations, and since it's toxic and poisonous. So the way we frame it matters a lot. So this way I framed it is not very nice. I don't like that point. So you can leave it, a good thing, but you can modify it, becomes better. Instead of being direct on ammonia, you say that waste gases during the production process can cause potential risks. That is like ammonia, and because of its high toxic and poisonous in nature. There's some new person here who is putting up the hand. Jeremiah Massa. Jeremiah. Jeremiah. Danny. Okay. Let's put in the chat. I'll be able to respond. Let's put in the chat. For social benefits, I'll not repeat. We already talked about all these. But look at this point. Job opportunity. But don't always, I want us to always put a small subheading and say, during the production process of ammonium nitrate, there are some social benefits. Maybe let me put it for you there so that we see it very well. I'm saying here, you say, during the production process, during the production process of ammonium nitrate, there are some social benefits which include, then you start job opportunity. This is a benefit identified for both skilled, not skills, both skilled and unskilled laborers, hence getting income. This enables, this is benefit explained. This enables them improve their standards of living, such as meeting their basic needs. This is the impact. Are you seeing that? Very nice, pregnant point. Then another one. But this one also needs to be adjusted very well. But let's see. Economic growth to the national treasure through tax revenue, hence infrastructure development. Okay. But this and this are almost the same. But this one is the best because it's very well explained. Look at this. Source of government revenue through what? Tax collection, leading to improved social infrastructures such as roads, schools, hospitals, markets in these communities by the government. Are you seeing that? This is a benefit explained, leading to improved standards of living among the residents. Are you seeing that? That is their impact. So you can see this point is very nice and can give you all the 6 scores. So surely, why should we get 0 in section B part 1? Unless there's a problem. Maybe that day you're sick, that's when I can allow you to get like maybe 6 scores. But if not, you're very sober and you have attended this lesson, there's no reason why you should get less than 6 out of 18. Let me check in the chat if we have any new question there. Teacher, I would want to join. Like I told you, please, you join. Use that link and then you can be able to join. The link is there. Just click on it, subscribe there. You will find there the link to the group. Which means 1 point is enough. Yes, 1 point is enough, but like I'm encouraging us, put 2 points, explain very well, and start with the best point that you are sure about. Yeah? Okay. Thank you. Okay, welcome. Let's run very fast. Urea. Now, urea is an interesting fertilizer. In only 3 lines, you're done with what? Urea. Tala. Was it Tala? Tiala. Are you still there? Whose microphone is open? Covenant. Yes, Covenant. Covenant.
Good
Okay.
afternoon.
Good afternoon.
I was asking, like, during the production of ammonia, the production process,
Mm.
do you have to write even how nitric acid is obtained?
First wait. When you're looking at what?
Like when you're writing the Haber process. Okay, like when you're writing when given an item of how to manufacture ammonium nitrate, and then you
It
have
is
finished
already
writing.
here. Ammonium
Yes.
nitrate. And I've given you 2 methods. There is this one. Look at this. There is this one where I've manufactured ammonia, and after I'm manufacturing ammonia, I just reacted ammonia with nitric acid, which I had as a raw material. Are you seeing that?
Yes.
So in this case, I didn't manufacture nitric acid. Instead, nitric acid was part of my raw materials. So what I manufactured is ammonia from nitrogen and hydrogen gas. But there is another method up here, the second method here, where I manufactured ammonia first, and after manufacturing ammonia, I went ahead to manufacture nitric acid. After getting nitric acid, I reacted nitric and ammonia to get ammonium nitrate.
Okay.
Yeah. Now,
Thank you, sir.
you read for us this one for urea. Raw materials. Let's be faster.
Raw materials for urea.
Check on your screen.
My screen, let me first see.
Now, Covenant is in noisy press. I will take you through faster because of time. So raw materials for urea, we are saying that we have nitrogen gas, hydrogen gas, and carbon dioxide gas. So you get your 2 scores. After that, production process, we are saying during Haber process, nitrogen obtained from air. There's something which I'm missing here. Nitrogen obtained from air reacts with hydrogen from natural gas in a sealed container. This is our vessel. Then here when you say react, this is our chemical process. At this pressure to form ammonia gas. So ammonia gas is purified, liquefied, and refrigerated. And here we have our equation for reaction between nitrogen, hydrogen to form ammonia gas. So both ammonia and carbon dioxide gas react in a sealed reactor vessel to form urea as a fertilizer, which is purified, concentrated, and this here we have conversion to the desired product. Concentrated, purified, and packed. And here is our equation. You get your 4 squares. Very simple like that. Very simple like that. And because we already looked at side effects, allow me not to take you through the side effects. When you get this video, you just pause, you note them down. But the good thing, we already know them. We already know them. Let's run very fast to ammonium sulfate, friends. Time. Time is not our good friend. Seeing hands increasing. Maybe let me hear from someone who has not asked. Aloyo, peace. Aloyo. Yes, Aloyo. Aloyo, peace, and Shiba. Okay, Aloyo
Good
first.
afternoon, sir.
Good afternoon. How are you?
I'm fine. So, I wanted to ask,
Mm.
if you give the side effects, will you give also the risk and medication?
In production processes, we don't have risks and mitigations. Risks and mitigations are in practical. Are we there?
Yes.
But here we are looking at an industrial process. We are doing at a large scale. So when you're looking at the large scale, we're looking at the side effects of the production process of that product.
Yes.
Yeah. So I believe that one is clear.
Okay, thank you, sir.
Welcome. Shiba?
Excuse me, sir.
Yes,
Are all
please.
these processes examinable or ammonium nitrate only?
I've not heard.
Are all these processes examinable or it's only ammonium nitrate?
Hey, let me see. That is Shiba. Shiba. They are all examinable. Now, listen, Shiba. When we are beginning, were you there when we were beginning this lesson?
Yes.
And I showed you the element of construct and the accessible areas, isn't it? Now, when you look at
Yes.
our syllabus, when you are, by the way, when you are doing all this, we normally based on the syllabus, yeah? And if you can give me just a minute, I can bring you even the syllabus, which is here. Are you seeing the syllabus on the screen? Are you seeing the syllabus?
Not yet. It's
Shiba,
not
you must.
clear.
It is not clear, but what are you seeing on the screen? Are you seeing it there?
Chemical reactions.
Okay, now here is industrial processes. Are you seeing industrial processes?
I'm saying chemical reactions.
Shiba. Maybe they may
Oh,
also
now I'm
open.
seeing it's there.
You're seeing it now.
I've
Now,
seen, yes.
I want to take you through here. Whatever you see here, just know is examinable. Yeah. So when you talk about copper, you look at the metals. In a previous lesson I had on Monday, we talked about manufacture of iron. We talked about manufacture of copper. We talked about manufacture of aluminium. Meaning, a question can be set about manufacture of iron, copper, and aluminium. Are you seeing that?
Yes.
Let's move on. Now, when you come to there is here importance of nitrate. Then here they are saying that you should be able to understand the process involved in extracting and purifying metals with particular reference to processes used in Uganda. Then on D, they are saying understand the importance of nitrates as fertilizers in food production and how they are produced from nitrogen in air. That is what we're looking at. How these fertilizers are produced from nitrogen in air. And the fertilizers we're looking at is ammonium nitrate, ammonium sulfate, urea. We have seen that all of those are nitrogen-based fertilizers. It doesn't end there. Look at down here. When you look at down here, it will also show you, understand the process of manufacture of lime. Are you seeing those who are talking about lime? Lime is part of the syllabus. So lime can be set. Cement can be set. Shiba, are you seeing that?
Yes.
Then the other one which we are going to look at is production of alkali and chlorine. Alkali we are looking at is sodium hydroxide. Sodium hydroxide and chlorine gas. And like I told you, chlorine gas was one of the questions that was said last year. So all these that we are talking about, they are examinable, they are accessible. That's why I told you practice makes perfect. It is a must. Two of these ones we are looking at, they will come, but we don't know which one. So what you need to do is to practice all of them. Okay,
Okay,
Eileen.
thank you.
Okay, welcome. Eileen,
Good afternoon, sir.
good afternoon.
I was requesting, can you share like this one, manufacturing of lime? Like we didn't study about it, but I wanted to know it.
Very much. That's why I'm going. If we can finish this very fast and then I go to that. I request, I know time is done. It is 4. How many minutes can we borrow? And we finish cement and lime.
20.
Let's put in the chat. Put in the chat, tell me how many minutes we can borrow. And then if you tell me to end here, it is okay. But someone is saying 1 hour, 20. Okay, 20 minutes are enough. Now, allow me to utilize only 20 minutes. Forever Young is saying end here. Another one is saying 0 minutes. Yeah, I know. But I may not come back for industrial processes. I want to finish. But allow me to be a little bit faster. And the good thing, I'll share this video. That one who is going off now, don't worry. You can still find this video later and you can find all this. Let me take you through very fast ammonium sulfate. For ammonium sulfate, it is just the same as ammonium nitrate. The difference is that for this one is coming from sulfuric acid, while for nitrate is coming from nitric acid. Are you seeing what the difference is? And the other method I used where I made nitric acid as a raw material, even here it can be the same. But for this one, I'm going to show you, I'm going to manufacture ammonia. I also manufacture sulfuric acid after I react the two. But it's also possible to get ammonia. After you get ammonia reacted to sulfuric acid, you get the product. Any of the two works. But for the case of detailed work, I'm giving it to you like this. Nitrogen, hydrogen gas, iron, then sulfur and oxygen gas. This sulfur and oxygen, this one are the raw materials for sulfuric acid if you have forgotten, yeah? So those ones who are asking how is the sulfuric acid manufactured? The process is also here. This is for sulfuric acid. This is for ammonia. So when you get ammonia, when you get ammonia, you react it with this, you get the ammonium nitrate. Not nitrate, ammonium sulfate. Are you seeing that? So for this one, you already know. Here you already have your 2 marks. Then here we're saying that during Haber process, ammonia is produced by reacting nitrogen obtained from air with hydrogen from natural gas in a sealed container. At temperature this one we already know to form ammonia. This one we have already looked at it. Now, after that, during the contact process, the sulfuric acid is produced by reacting sulfur in air to form sulfur dioxide gas. This is a chemical process. followed by catalytic oxidation of sulfur dioxide to form sulfur trioxide gas. We have put all the equations there. This is the chemical processes which are indicated there. After that, the sulfur trioxide gas formed is then reacted with in sealed reactor tank containing concentrated sulfuric acid to form urea, which is dissolved in water to form pure sulfuric what? Acid. This is sulfuric acid. So here it is equation for formation of ureum and dilution of ureum to form our desired sulfuric acid. Then after that, we are done. We say both sulfuric acid and ammonia are heated in sealed reactor tank to form ammonium sulfate. You see, conversion to our desired product, which is purified, that is our PR, concentrated and packed. And you get all your marks. Surely, there's no need of us cramming or want. If you know ammonia, you know sulfuric acid, then ammonium nitrate, ammonium sulfate becomes very simple. Look at side effects. Refer to the previous. I don't need to repeat that. Social benefits, refer to the previous manufacture. And then I can take you through the last bits, the ammonia cement. Then for sodium hydroxide, what I'm going to do for sodium hydroxide, we already talked about it. I'm going to put for you that link in the chat so that you can follow it. It's the one I'm getting here. Let me just give you that link so that at any time you can just follow. Immediately after this lesson, you can follow the link for manufacture of sodium hydroxide. Right now, I want to take you through only sodium hydroxide, and I want to take you through only cement and lime. Then for sodium hydroxide and chlorine, the link is here. Let me give it to you here. Just a minute here in the chat. Let's check in the chat. I'm just putting it there. This is for sodium hydroxide and chlorine gas. Check in the chat. I'll put it there. So for sodium hydroxide and chlorine gas is already there. Is it necessary to state that part beginning with both? Is it necessary to state that part beginning with both? Anyway, depending on our English, you can just say ammonia is reacted with this, yeah? So it is not necessary, but our English is the one which is there, is the one which may differ there. But a good thing is when we see that the two are reacting. I want to maximize the few minutes we added ourselves. So on our manufacture of cement, look at this. The raw materials, we are saying that we have the limestone, sand, and clay. So these are the major raw materials during the manufacture of cement. So here you get 2 marks. You recall cement, this one came in 2024. This is the one which came in UNEB 2024. It was cement and manufacture of copper. Those were for 2024. Now look at the production process. The limestone, which is our raw material, obtained from the quarry is mixed with sand, which is also our raw material, and clay in correct proportions and crushed into fine powder. Now, this is a physical process because when you crush to fine powder, there's nothing, we are changing the chemical composition. You're just changing the state from maybe a big stone into fine powder, yeah? So that is a physical process. Then the powder is then mixed with water and allowed to flow down the rotating tank. Or we can use the cylinder or the cement one, clean, but use only one for you in your work, where it is strongly heated at about 1,500 degrees Celsius. Then the limestone decomposes into calcium oxide and carbon dioxide gas. That is a chemical process. Calcium oxide reacts with sand, forming calcium what? Silicate, and also reacts with aluminum oxide, forming calcium aluminate. So these are our equations, but I said you can use also the word equations. Yeah? Huh. I can say hand there. Put in the chat. I'm going to find your question there. Put it there. I check it. Calcium silicate and calcium aluminate form a mixture called what? Clinker. Yeah? So gypsum is added to clinker to modulate the setting of cement and lumps, cement and the lumps are then crushed by machine to obtain fine cement powder conversion to the desired what? Product. And you get all your 4 scores. I think that there's someone who had a question. Teacher, when do I put radicals into consideration when finding the molar mass? Huh? May you please send these documents to the WhatsApp group. Thank you. Like I said, we always share these documents, but it's good also to keep on following, not waiting for the documents, because documents may not have everything that we are discussing. This video will also be shared in your group, and then you'll be able to still follow in the video later after the session. So here we have finished for cement. Now look at the side effects. This is what I always tell us. After looking at the production process, put a statement like this. The process of production of cement has some side effects, which include, I think, that one makes, when the examiner is scoring your work, doesn't start looking for the side effects. Where are they? You have already told this person. Are you saying that? So I'm not going to read a lot. Let me just put it there. You can take a screenshot because of time, and then you can go through. But the good thing, you see, let me use a red pen here. Here, water pollution is our danger. Then here we're explaining how. Effluent discharge from the cement plant can contaminate water bodies, affecting aquatic life and quality of water. This is the danger explained. This can be mitigated by treatment of wastewater through sedimentation and filtration before discharge. So this is the mitigation. Then we have other 2 points, but like I said, put only 2 points which are very well explained. Then you can also take a screenshot for this production process. The social benefits, they are all there. The good thing, I've already given you very good social benefits, but always put a subheading. The production process of cement has some social benefits, which include, then you put. Don't start from nowhere and then you put a paragraph. Source of employment, from where? And there's a point I gave you which is very nice for source of employment opportunities to both the skilled and unskilled. So you can even modify this. I believe now you're very good writers of social benefits, points which are very well explained. Like some people were asking about lime, just lime very small like this, small like that, very simple like that. Let's go through it, and we call it a what? A day. Maybe when you say low material. So the low material here is limestone. That is the major low material. Is the limestone. Now, and maybe what we can add there is just water. Those are the 2 things that we can include under the raw materials for manufacture of limestone and water. So look at this. Limes from limestone is first ground into fine particles. When you're putting into fine particles, that is a physical one process. Then fed into the kiln. Kiln is the vessel. Heated at about 900 degrees Celsius to form quick lime. Now, this is a chemical process. Look at on one statement, and you're having very many points. Irene, what is it? Irene.
Teacher, nothing.
Okay. What about Madrine? Mercy.
Master,
Mm,
I was asking that, yeah.
mm.
I never understood this manufacture
Which
process.
one? Which one?
Cement.
Oh, I'll take you back there, but we have only 5 minutes. But have you taken the screenshot?
No, I've looked for it, but I'm not seeing it.
Okay, I'm going to bring it back. You take a screenshot and then you can put down the notes. Eh?
Okay.
Okay. Herep. Yes, Herep. Herep. Mm. Yes, please.
My question was that
Mm.
is it necessary or it's a must to say that limestone is mined from a quarry, or it just looks like limestone is mixed with sand?
On cement, eh?
Yeah.
It's not very necessary, but if you know where it is coming from, which is still okay. You're not denied a score for that, yeah?
Oh,
Yes, so you're not denied a score. Yeah, thank you for
okay.
that. Okay, now you can take a screenshot for the manufacture of line. So here we have that after crunching. You see, I was still showing you that in one statement, you have the physical process identified, the vessel identified, the chemical process identified, you have your equation here. Then the quick lime, which is calcium oxide, formed is then cooled shortly before water is added to it, which forms slake what? Lime, which forms slake lime, the calcium hydroxide in a sealed reactor vessel. So the slake lime formed is passed through purifiers, this is purification, to remove any impurities and water, allowing it to be concentrated, ready for packaging. And you get your 4 scores, you get your 2 scores on the raw materials. I may end with Kevin. Kevin.
Master,
Yes, please.
good evening.
Good evening.
Master, I'm asking that
Mm,
here you have said
mm,
the quick lime
mm.
formed is cooled shortly. At what is it? At what shortly? At what is then cooled shortly? Okay, at what
Eh.
percentage? At what
Oh,
percentage?
okay. Thank
Yes.
you for that. Thank you. Yeah, thank you for that. So he's asking if we say quick lime is formed is then cooled shortly. I don't know which term can we use. Let me check in the chat whether someone is. So I'm requesting take me through extraction of aluminium. That one we finished. You can check on the video on in the YouTube. It is already there. For aluminium, maybe to help you out, I can also put for you the link for that. Let me just give you a link for that. Aluminium. Where are you? It was part 1 for industrial processes. The one who is asking for aluminium. So when you check on this, you get for aluminium, you get for even others. Yeah. It is here in the chat. Those ones who missed the first session, the work is there for metals. Extraction of metals. So you can get the work there. The good thing is there. So someone is saying that at what temperature? Cooled shortly to what temperature? Teacher, please first finish the lesson, then take questions or answers, then or answer them in the chat. Okay. Thank you. Thank you for that. Like I said, my lesson has come to the end. My lesson has come to the end. For dangers, side effects, just take a screenshot. I've put them there. Take a screenshot. Take a screenshot for side effects, and then social benefits. Also, you can take a what? A screenshot. About sodium hydroxide and chlorine, I have already given you the link. It is just 20 minutes past 4. I wouldn't take more time apart from just wishing you the best. Thank you for paying much attention, for discussing. And the one who was asking about the cement, please, the production process is here. Just take a screenshot, then you can put down the notes later. Cement is there. Take a screenshot, just a minute. Take a screenshot. It is there. Take a screenshot. If you are finished there, you can also take for the last part there. That is it. But a good thing, this video will be shared. You'll be able to go through and you practice more. These processes are very easy for learners. Otherwise, I want to thank you very much for paying much attention, for participating, and being active throughout the lesson. We shall be meeting again next Monday. But as we wait for the next Monday, let's make sure that we are practicing, we are reading. You have seen that we have a number of them. We have very many industrial processes, and the only thing you can do is to make sure that you practice. Practice makes it perfect. Practice makes perfect. Otherwise, I want someone to read us in the closing prayer. Someone, Enoch Deno. Yes? Deno? Akankwasa failed this. You unmute and lead us in the closing prayer. Okay.
Humble yourself for prayer. Lord Jesus Christ, we thank you for the gift of opportunity that you have given us to come and read. As we are going to break off, Abba Father, we pray whatever we have been taught, may we master it, Lord Jesus Christ. May you be our guardian, Abba Father, as this is our final year, Abba Father. We pray for excellence and may we excel, have been able to pray this Christ our Lord. Amen.
Thank you. Thank you very much. Let's meet again next week. Have a blessed time.
Yeah.